So let's review rationals and radicals. Remember that an expression has no equal sign. So first we're going to start with rational expressions. When you are asked to simplify a rational expression, you always want to factor completely. So simplifying means factor. And then you want to cross out any common factors. And you can only cross out one pair at a time. So for example, if I had x squared plus 7x plus 10 over x plus 5, I would have to factor my numerator using the AM method, and it would be x plus 5 over x plus 2. And then I could cancel or divide out my factors that are the same. So this would reduce to x plus 2. And then you're going to rewrite it, and that's it. However, please remember there is a special case. If I have something like x minus 3 over 3 minus x, it's subtraction, and it's the exact opposite. That gives me -1. But if it's addition, x plus 3, 3 plus x, that equals 1. So only for subtraction do you have the special case. Rational expressions come up most often as a multiple choice question. And for multiple choice, you can use your calculator trick. You will usually see the phrase equivalent. And you can put the question in Y1, the answer choices in Y2, and you're going to look for matching values in your table. Undefined expressions. This is when something is in the denominator and we're going to set it equal to 0. So something is considered undefined when the denominator, which is the bottom part of my fraction, is equal to 0. We set the expression in the denominator equal to 0 and solve. These are also known as excluded values. So if I had that expression up top again, x squared plus 7x plus 10 over x plus 5, I would set my denominator equal to 0, and x cannot equal -5. That's my excluded value, which is important when we go to solving. So the calculator trick here is you type the entire thing into y equals, and we're looking for the error. Then we have adding and subtracting. So whenever you are adding and subtracting rational expressions, you must have a common denominator. I can't add 1 over 3 plus x over 5. I have to have a common denominator. So you're always going to factor first before determining your LCD. If anything, you can always start by multiplying your denominators together. You're going to multiply each fraction, top and bottom, by what's missing in the LCD. And you're going to simplify by combining like terms in your numerators, and you're always going to keep your denominators. That's the #1 mistake students make here. You can't cross out your denominators. Think about something like 1 over 7 plus 2 over 7. This is equal to 3 over 7. I cannot say it's equal to 3. It has to be equal to 3/7. If you are asked to prove, it would say algebraically prove, you're going to follow the same process. You're going to cover up one side of the equation, work with one side only. The last step should be those two equal to each other. And you never want to cross over the equal sign by subtracting on both sides or something like that. Work with one side at a time only. Let's move on to equations. So a rational equation. It's very similar to adding and subtracting. You're first going to start by determining the LCD of all of your fractions. Same tips for finding your LCD. Still going to multiply the top and bottom by what's missing. But only because it's an equation, you can now cross out your denominators once they match. So 1 over 7 plus x over 7 equals 3 over 7. All of my denominators match. 1 plus x equals 3, and I can now solve. The important part of solving is that you always have to check your solutions, and we're going to use our calculator trick to check. I always like to do that first, even before I solve it algebraically. So if they don't match, or if your solutions don't check, they are known as extraneous solutions, and you are going to reject them. If after you check your answers, you have no solutions left, they all reject, you're going to write no solution as your answer. On a multiple choice question, you may see it as the empty set, a set of these fancy brackets with nothing inside. So this check is the same as this calculator trick, which comes up a lot of times on multiple choice. Left side goes in Y1, right side goes in Y2. If it's multiple choice, you have the benefit of checking the values that are given to you in the answer choices. And you can go to the table by hitting second graph, and you want your Y values to match. If they match, it's your answer. If you don't have a multiple choice, or if it's decimals, you're going to have to use the point of intersection by hitting second trace on the graph. So remember, we always hit zoom 6 first. Then if we need to adjust our window or zoom fit in order to find those points of intersection. Second trace 5, and we're looking for the X value only. Lastly, we're going to radical equations. So when we are solving a radical equation, you want to isolate both sides and then raise the reciprocal power. So I have something like this. I can't square both sides to start. I need to add 7 to both sides first, and then I can square both sides. The reason I'm squaring both sides is because it's a square root. If it was a cube root of x plus 5, I would be cubing both sides. You're raising to the reciprocal power. Then you're going to solve that equation that's left, and you are always going to check your solutions with the same calculator trick that we just reviewed for rational equations. We love this topic because it comes up a lot on multiple choice, Y1, Y2, find the match. Once again, if it's a free response and all of your answers reject, there's going to be no solution, just like in the rationals with the empty brackets. Finished.